Hello Beyonders, it's been a while. Just like always, today we'll talk about AI in a very informative way that often gets overlooked. This video will talk about how artificial intelligence is still on an upward trajectory with unbelievable momentum. We'll get a general sense of the landscape in 2024 and beyond. This video is jam-packed with a lot of detail. If you're ready, then so am I. Let's dive in right away. This is a very extensive topic, so how do we dissect it? We'll start off by discussing the domains that AI has an impact on. This list is not exhaustive, but the main ones are text, sound, image, video, and robotics. Just like human senses, AI needs these modalities in order to interpret the world. Each modality has subsections, and sometimes they intersect or merge together to form multimodal models. We'll talk about some of them in this video.
I've always felt would be the most beneficial and consequential technology for humanity. Human beings in our society would have 5 senses, and the world we built and the media we consume is in those different modalities.
The technology spans several industries like transportation, healthcare, education, and almost every aspect of society. Because this can easily be a 10-hour video, or even more, we'll touch on these AI topics on a much higher level, and then perhaps I can make follow-up videos if necessary. Before we talk about AI in 2024 and beyond, let's first take a look at how the industry has evolved in the last few years. I made an in-depth video on the history of AI over the decades. I'll share the link in the descriptions below. In this video, we won't go that far, but you'll still understand how far we've come. The concept of artificial intelligence has been around for centuries. Devices that can make our lives easier have been around for a few millennia. It's embedded in our DNA. In fact, early tool making dates back over 2 million years. Each turn of human technological progress spurs a new era of unimaginable developments, and AI is no different. Charles Babbage had earlier computer inventions in the 1820s, but these were mechanical. The Jacquard machine, which used punch cards to speed up textile production and received a patent in 1804, had an impact on these inventions. Fast forward, punch cards were used to communicate with the first electronic general-purpose computer in the 1940s, which filled an entire room. Ideas of intelligent machines were popularized by Alan Turing in 1950 with his Turing test. Could a machine be so intelligent that it was indistinguishable from a human? This led to the term AI being coined in 1956. The first chatbot, Eliza, was developed in 1961 as a direct test case for the Turing test.
Eliza is a computer program that anyone can converse with via the keyboard, and it'll reply on the screen. We've added human speech to make the conversation more clear.
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
As you can see, each technological milestone informs the next. We're skipping a lot of detail here, but that's okay, because we're here to discuss modern AI, not its history. All through the AI winters, from IBM's Deep Blue in '91 to AlexNet in 2012 and AlphaGo in 2015, it's been a journey, and now we're on the precipice of a new era. 2023 saw many exciting AI breakthroughs following up from the year before. OpenAI released GPT-4, AI agents automating workflows were a big thing, and of course, who can forget all the drama surrounding the OpenAI CEO firing and rehiring all in a matter of days. It's been a roller coaster ride, but very exciting at the same time. In the next few minutes, we'll talk about the present landscape of AI across all the different modalities, so stay tuned. Text is one of the most popular applications of AI today. We mentioned Eliza earlier in the video as one of the first chatbots ever developed. This wasn't truly AI, but was logic-based, a set of rules to guide the program. Current AI text systems, or LLMs, like GPT-4, Gemini, and Llama, rely on huge compute power to produce text that can now pass the Turing test. What a full circle moment. Testing these LLMs is more complex now, with benchmarks that measure reasoning, truthfulness, and other important metrics that can improve these systems over time. If you've interacted with these LLMs, you've probably noticed they hallucinate or make up factually incorrect statements. This is the biggest hindrance to text-based AI systems. You can never be fully confident in these systems, and that's why it's good practice to go over AI results with proper due diligence. There are several camps that suggest different methods to fix hallucinations. One camp suggests that the current architecture of LLMs is sufficient enough to fix the hallucination issue. All we need is some time, more computation, and a few more tweaks. Proponents of this theory, including OpenAI's Ilya Sutskever, believe LLMs are much more than statistical predictions of the next word.
Predicting the next token well means that you understand the underlying reality that led to the creation of that token. It's not statistics, like it is statistics, but what is statistics? In order to understand those statistics, to compress them, you need to understand what is it about the world that creates those statistics. And I'd argue that this should make it possible, not indefinitely, but to a pretty decent degree, to say, well, can you guess what you'd do if you took a person with like this characteristic and that characteristic? Like such a person doesn't exist. But because you're so good at predicting the next token, you should still be able to guess what that person would do, this hypothetical.
On the other hand, Yann LeCun from Meta believes LLMs need a restructuring of the Bayes transformer framework to something that allows LLMs to have grounding in the real world. He's been working on ways of realizing this future. One such piece of research is his non-technical paper on autonomous machine intelligence, which I'll link in the description below. In a nutshell, he describes a new framework that learns from the real world through videos, for example, and has features that are similar to those of humans. This includes memory, planning, and reasoning, an action layer, and energy-based controls where high energy aligns with discomfort like pain, and pleasure assumes a low energy.
Through vision, and try to put a number on how much information a 4-year-old child has seen during his or her life. And it's about 20 megabytes per second going through the optical nerve for 16,000 wake hours in the first 4 years of life, and 3,600 seconds per hour. You did the calculation, and that's 10 to the 15 bytes. So what that tells you is that a 4-year-old child has seen 50 times more information than the biggest LLMs that we have. And the 4-year-old child is way smarter than the biggest LLMs that we have. The amount of knowledge it's accumulated is apparently smaller because it's in a different form. But in fact, a 4-year-old child has learned an enormous amount of knowledge about how the world works. And we can do this with LLMs today. And so we're missing some essential science and new architectures to take advantage of sensory input that future AI systems would be capable of taking advantage of. And this will require a few scientific and technological breakthroughs, which may happen in the next year, 3 years, 5 years, 10 years. We don't know. It's hard.
His proposal still requires a lot of work, and there are still several unanswered questions. But this goes to show you the problem of hallucination is a big one, and the biggest scientists across the world are working on it. There are other issues like context length that limit how much text LLMs can generate. But several research papers have developed interesting solutions, and it's only a matter of time before they are implemented in products like ChatGPT. We can now shift our attention to AI sound. Under this domain, there are important categories like text-to-speech, speech-to-text, and AI music. Traditional voice assistants like Alexa and Siri use AI to interpret user input. YouTube uses its speech-to-text model for generating subtitles for videos. TTS and STT models are some of the most advanced AI models compared to other domains. However, there's still huge potential to improve, especially in text-to-speech. Most of them still sound robotic, although there have been drastic improvements like Bark and 11 Labs that aim for natural-sounding voices.
Hello and welcome to Nostalgic, the show that takes you back in time. I'm your host, Laura. In today's episode, we will talk about the time I almost wrecked my home with Susie, my best friend.
One of the biggest issues with AI sound is music generation. With TTS and SCT, you provide a guiding input like text or speech, which the AI encodes. For music generation, simply providing a description of the music is much more difficult because the machine learning model has to generate music that is consistent, realistic, and matches the request. The longer the music sequence is, the harder it is for the AI to generate. There have been some incredible AI music models that have been released over the last 2 years. Important releases include MusicLM and SingSong from Google, AudioCraft from Meta, and Lyria from DeepMind. I particularly found Lyria mesmerizing, especially for artists and producers. All you have to do is guide the AI to produce the sound you're going for by humming, and it generates the music for you. It's simply amazing. We've previously discussed how AI music works on this channel, and I'll make sure to add that to the descriptions below. We can only expect these to get better over the coming years. It'll make the music making process easier and faster. If you're an artist watching this, let me know what you think about some of these innovations coming out in the music industry. There are several musicians who are against AI music, while there are others like Lupe Fiasco and Grimes who are more inclined toward the idea.
It's called text effects. These tools, they generate similes, they create acronyms, they parse words. It's an entire suite of different kind of possibilities dealing with text and language.
I know I want to say held up to the lips of a marauder, but I want to do explode with marauder. Mary Water, yep, my raider, more rudder. Ooh, that's good. Yeah, I like that. So we'll do that.
Our next AI modality will be images. This is one of the most popular applications of AI. DALL-E 3, Midjourney, Stable Diffusion, and Leonardo are some of the most frequently used AI image generators. It has been incredible to see what some people have been able to generate with these systems. High-quality images can be developed across different styles, from realistic to anime and beyond. The dinosaur in the room is obviously copyright issues and how AI models are implementing huge sources of copyright data. We'll discuss this some more in the policy section of this video. Currently, the primary issue with AI images is instruction following. The more complex the description, the higher the chances the AI model will miss important information. For example, prompting the AI to generate an image of a cat and a dog with various elements seems to be successful until you realize the model missed the part where the cat has to be looking at the door. The image doesn't fully adhere to the description, and this is a problem with current image models. Several labs like OpenAI have improved on high-quality instruction following models. DALL-E 3 is one of the best ones released and fulfills most of the descriptions in a text prompt. Midjourney is still the most popular AI image model for high-quality images. All through 2024, we'll see more convincing images from AI, which is already a problem in this era of misinformation. We'll talk more about this later. If you're an artist watching this, are you threatened by these systems? Or do you feel empowered? That's a separate discussion on its own. Let me know what you think in the comments below. Obviously, when talking about images, the next level of progression is video generation using artificial intelligence. On a basic level, videos are just images put together. How many images can be shown in a given time period? The more images that can be shown per second, the smoother the image will be. This is simply the frames per second. Naturally, all the issues we currently face with AI images also apply to video. Video, however, has additional issues like temporal consistency. Generating one image is difficult. Talk about generating multiple related images that tell a story over time. The video has to be realistic, and the movements of the characters must simulate real-world videos. For example, a video of a dog walking must have all four legs move realistically, and the dog in each frame should be the same with no change in features. You can already see how this is a problem. Aside from temporal consistency and realistic movements, high-quality videos are an issue too. But in the last year or so, videos have become increasingly high quality, from Google's ImagenVideo to Pika Labs video models. Most video models only produce a few seconds of video because of the complexities mentioned previously. Longer videos will require more computation and a better architecture to address these issues. Today, the most impressive AI video model I've come across has been Google's Phenaki. This was released over a year ago. Their model could generate AI videos that went on for minutes. The quality was good for that time, and the temporal consistency was much better, even compared to some of the recent models we've seen. You can tell a story, and Phenaki will generate a consistent video. Here's an example of a 2-minute video, where it starts off from a city, and then the camera zooms into a spaceship until we see an astronaut. There are a lot of changing factors here, but the video sticks to the overall theme. Remember, this was before Runway and Pika got popular. I'm still waiting for an update on this. My intuition is that Google will merge these high-quality models, like ImagenVideo, to produce a high-quality long-form video. We might see this by the end of 2024 or early 2025. Fingers definitely crossed for that. I've discussed video models dating to the very early versions like CogVideo and Nuo Infinity from Microsoft. Do check them out if you're interested. We've come a long way since then. Hollywood is only waiting for the technology to get better before they go all in. An early sign of this was Marvel's Secret Invasion intro, which used AI. Another latest addition was Kanye West's latest album Sneak Peek, which was a dark horror AI-themed video. In the course of making this video, Google announced Lumiere, another text-to-video model that produces high-quality videos from text. This is an improvement to their ImagenVideo model I mentioned earlier. I look forward to seeing their longer-form videos. We'll end part 1 here. Join me in part 2 where we dive into the more advanced AI techniques. We'll also talk about the technology's impact on our lives, from fake news to future robots and government regulation. Thanks for watching Beyond today. Until the next video, it's goodbye.